Hi, sorry I'm not in class today. We're going to continue with our discussion about the atmosphere. We're going to do the notes for topic 6.2 on stratospheric ozone. I'm going to take you through the lecture here. Please follow along with your notes. So last time we talked about how there are 4 different layers of the atmosphere. Over here, this picture on the right, troposphere. That's where weather takes place. That's the lowest level. Then the stratosphere, the mesosphere, and the thermosphere. And the reason why we have 4 different layers is that gases have different densities and rise to different levels. That's what creates the 4 different layers. And the interesting thing about those gases is that they have different abilities to absorb and reflect different types of solar radiation. That's what makes life on this planet possible. And so today we're going to talk about an interesting gas which makes up the lower level of the stratosphere here. It's called ozone. Ozone is not to be confused with oxygen. Oxygen is O2. Ozone is O3. And it is the lower level of the stratosphere. Sometimes it might be the upper level of the troposphere. Now, the important thing about ozone gas is that it absorbs UV radiation, which is extremely harmful to life on Earth. And so the ozone layer is really what makes living possible on Earth. Let's take a look at the next slide here. Now, the interesting thing about ozone is that if you just leave it alone, it actually not only absorbs UV radiation, but it keeps recycling itself and replenishing. So here's pretty much how it goes. So ozone in the stratosphere is mostly produced because of UV radiation. So UV radiation, in the form of photons from the sun, is reacting with oxygen, O2, not ozone. And the UV radiation breaks oxygen, O2, into 2 oxygen radicals. These radicals then recombine with other oxygen molecules. Pretty simple math here. 1 oxygen plus 2 oxygens makes 3 oxygens. So that's how we make ozone layer. And then it can be also destroyed by radiation, and it is destroyed because oxygen, or ozone, O3, combines with an oxygen radical. 3 plus 1 makes 2 oxygen molecules. 2 times 2 is 4. And so these oxygens are the end product, but then they can go back to the beginning, recombine, and form more ozone, and the whole thing keeps replenishing itself. So if we just leave it alone, the ozone layer will just be there always for us, protecting us from UV radiation. The problem is we don't leave it alone. We've done something really naughty with it. So a number of years ago, people were taking pictures of the atmosphere, and they noticed over Antarctica, there was kind of a hole opening up here. And that hole is there because there is an ozone layer. So at this part of the world, UV radiation was actually getting through and hitting the continent of Antarctica. Many reasons for it. Has to do with gases migrating there, but we won't go into that. The point is, the ozone hole was appearing because it was being destroyed. Now, why was it being destroyed? Well, CFC molecules, chlorofluorocarbons, which are man-made products, and they were typically used in aerosols and propellants, they were interacting with ozone. And what happens then is every chlorine atom, we get chlorine from these chlorine fluorocarbons, interacts with an ozone, and it can destroy up to 100,000 of them. So these chlorines, which came from CFC molecules, were breaking down the ozone layer. Now, the good news is it first started to appear over Antarctica, where there aren't too many people living, but it started to get bigger and bigger, and this was a real problem. So what did we do about it? Well, first of all, we had to recognize the danger. UV radiation is extremely damaging to life on Earth. It damages the human eye. We're not geared for absorbing that sort of spectrum. It destroys our immune system. It's a big cause of cancer. It interferes with photosynthesis, and it causes a lot of other mutations to our DNA. Not a good list of things. So what did the world decide to do about it? Well, this is one of those few times where the world really came together and did something that made a difference. So there was a large conference called by the United Nations. Lots of countries attended it, and they signed an agreement called the Montreal Protocol. It was ratified by like everybody. And what they decided to do was to phase out all of these man-made products that were using CFCs. So, for example, when I was growing up, hairspray, you wanted to put something on your hair or underarm deodorant or whatever was in a can that you sprayed with an aerosol. Typically, we don't do that anymore. We have roll-ons, right? So we got rid of those, or we have pump sprays that don't use aerosols. So they phased out a lot of these products. And slowly, the hole started to repair itself. Because remember what I told you, if you just leave it alone, the cycle keeps repairing itself. If we continue on this path, the hole should pretty much be gone by 2050. This is really one of those success stories where an international agreement really made a difference. However, there's still some countries that are holding out and using products that are destroying the ozone. We call these products ODS, ozone depletion substances. So why do some countries use them? Well, surprise, surprise. If you look at this map over here, it's probably a lot of LEDCs, right, that are using it. And in all fairness to them, that's not their big concern, right? It's very expensive to switch on over with new technology to get rid of aerosols. There are a lot of products still in existence there, so they have longevity. It's expensive to update equipment. It's hard to make the transition, and it really makes an investment. And a lot of these countries just don't have the money to do that. Okay, let's go back to our discussion in general of greenhouse gases. So now we understand that ozone is one of those important greenhouse gases, and we understand that there are chemicals like CFCs which can destroy greenhouse gases. We call the ability of something to destroy a greenhouse gas GWP, global warming potential. Sometimes things have a very small GWP, that's good. Sometimes they have an extremely large. Now, the standard that they use is in terms of carbon dioxide. So everything which is destroying a greenhouse gas is relative to the effect that carbon dioxide would have. So you see over here relative to CO2. So look at this guy, for example, CFC 11. Wow, it's 4,000 times worse than adding carbon dioxide to the air. This is really, really bad. What I want you to do today is you will all be assigned a different greenhouse gas, and I want you to do a presentation to show what it is and how effective it will be at destroying greenhouse gases. Now, GWP is one way we can think about it, but there are other ways. So one of the ways is it artificial? Are things naturally occurring and they'll go away, or are they artificially being put in by human industry? Another way we could think about it is longevity. Yeah, it may not have a very strong GWP, but maybe it'll last for a long, long time. So we want to consider all these things when you do your presentation today.